labels and legends. Labeling and axes. So labeling axes is actually fairly quick, fairly easy to just get started. We can very quickly apply a title, an X label, and a Y label to this plot that's otherwise completely unlabeled, and I have no idea what I'm looking at. Although I do know it's a sine and cosine trigonometric function. But what I can do is I can use the .set method, I can set a title, my X label, and my Y label, and I can convey, just add a little bit more context to what it is that I'm looking at here. Additionally, Matplotlib has methods to give you just a little bit more control over each of these label settings. So I can use the actual .set_title method to set the text of the title, but also its location, where I want it to exist. So typically it's on top center, but by passing log equals left, my title is now on the top left. And I actually have met people who very much enjoy having the title on the top left instead of being centered. I think it gives it a sleek look, and it gives you a little bit more white space to play with if you have groupings or anything like that that you want to include on top of your title, on top of your plot. You can also use this pad argument in order to move your title, or any label really, both the X and Y label have these same arguments, to move the title or whatever text it is further away from the axes. And that's how you can get really quickly started with just adding title, and X and Y label to your plot. Matplotlib makes it very convenient. I should mention, this axes object, it's returned by data.plot, but we've also made them explicitly. If I were to use matplotlib subplots, right, and you'll see me do figure, comma, axes equals subplots. If you have access to the axes object, you can change just about anything about any plot. From the axes object, you can get things like the figure, you can get anything that's drawn onto it, the X or Y axis attached to it. So you'll see me use this a lot, and that's why I'm mentioning it now, is because whenever I'm using Matplotlib and I'm using something that takes away a little bit of my control, I'm looking to find this axes, because that is where I can do all of the work in order to make it pretty. So let's talk a little bit more about how we can annotate our data. And so what we can do here is, if I go back to using pandas, I can show you that once I pass this subplots equals true, right, and I'm no longer getting a single set of axes back, I'm actually getting multiple. You see here I end up with 2 axes, but what I want to highlight to you is that when I print this object out instead of showing it as a graph, you can see that it's actually, right, a 2-dimensional array of axes objects. And what this means is that I no longer have the ability to use this .set title, because this is not a single axis, this is many. And so you'll see here that even when I try to use set title, I get an error. It says numpy nd array has no attribute set title. And so what we have to do is we have to iterate over these axes, and we can use, and what's great about it being a numpy nd array instead of a list of lists, is that we can actually use some numpy notation in order to make our lives a little more convenient. So here I'm just zipping the columns of my data frame with the flattened version of the axes, right? So we get rid of all that 2-dimensional nesting. And I simply add a label, a title, and I remove the legend because I don't want to see it there. And so we're able to actually add separate titles to our separate axes by just iterating over them and setting them manually. Like I mentioned earlier, we have access, if we have access to the axes, we have access to the figure. If we have access to the figure, we can do a lot. And so you'll see here that I'm just accessing the very first instance of axes from, right, my nd array of them. And then I use the .figure attribute here to get the figure back out. And with the figure, I can actually add, you see this subtitle, sub X label, sub Y label. And what I'm doing here is these are called super title, super X label, super Y label. And what these do is that they are a top-centered text for the title, a left-centered text for the X label, and a lower-centered text for the Y label on the canvas, on the figure, right, my sheet of paper itself, not attached to any axes. And so these are great when you're reaching for, to try and get labels that are applied to multiple sets of axes within the same figure. And so, although each plot has its own title of whether it's sine or cosine, I have my figure title, my super title, a trip around the unit circle. It just describes what you're going to see in each plot that I've drawn here on this figure. And since they both share the same x-axis, I decided not to label them individually and instead use a super X label instead. Same with my Y label on the right. And so the figure gives us great ability to draw things that help us annotate our individual axes objects. Speaking of annotations, you can add any arbitrary text to figures just with the .text method. And this method also works for axes. So if I wanted to add text into the center of my figure, I can simply just specify on my proportional grid system, proportional coordinate system, 0.5 and 0.5, meaning halfway on my figure on the x-axis and then halfway up my figure on the y-axis. I can put this text and I can have it center aligned, right? And this is important to actually having the text be centered because this dictates what this point refers to, right? Does 0.5 mean the left of the text starts at 0.5, or does it mean the center of the text or the right of the text? You'll see me use this a lot. Now, if I wanted to add text to an axes, well, I know that the axes objects also have a .text method. So let's see if I can add text to the top center of my left axis as I've specified here. Interesting. It's close, right? We're kind of in the ballpark, surprisingly, but it's not actually in the top center, right? The text in the figure, the center of the figure, that's very centered. But this is off to the left of my axis. I really wanted that top nice and centered. And what you're actually seeing here is that I've passed in 0.5 for my x and 0.7 for my y. I was hoping that the 0.5 would get me halfway across the bottom and the 0.7 would get me 3/4 of the way to the top. But what it's actually done here is it's using my data coordinate system. It's actually looked at my x-axis, gone to the value 0.7, just below 0, or 0.5, I should say, and then goes all the way up to 0.7, and that's where it drew the center of my text object. And so that's not actually what I wanted. I want text in the top center of my left axis. And how we can do that is we actually have to reach for something called a transform. And all this is doing is saying, instead of using the data coordinate system, use my transaxes, use my axes proportional coordinate system. And you'll see these ideas of coordinate systems comes up often again and again. Whenever you want to put something in a very specific location, regardless of what the underlying data of your plot is, I will always recommend that you use either the axes or the figure coordinate system. And what happens here when I run this is we get text that's actually in the top center of my left axis. And I can do the same thing, right? Draw text on my right axis in the bottom center that you see here. This gives me very fine-grained control of where I put annotations. Now, where might this be useful? All right. Well, it becomes useful, this idea of grids and coordinate systems becomes useful when we want to place things like, as you saw, text, but also legends. And if you look at the Matplotlib documentation, you'll see that to draw a legend, you just call .legend. It's so easy, so convenient, except for when it's not. If you look at the top right of my plot here, you'll actually see this little empty box. And what that is that's Matplotlib's attempt at a legend, but my data that I passed it was not labeled. And so what I need to do for this to work is actually pass a label for each thing that I've drawn onto it. In this case, I need to pass a label for each of my sine wave and my cosine wave. And when I do that, we'll see that this ax.legend actually works. The legend's now in the lower left-hand corner here. And that's because Matplotlib defaults to what they call the best location, and that's the location where the legend is least likely to overlap with the things being drawn. Nice and convenient. But you can have very fine-grained control over the placement of your legend and also how it looks. For instance, you can pass location equals upper center in order to place it in the top center. I can also pass ncol equals 2 to split my legend into 2 columns instead of just being one single column. Additionally, I can use this bbox to anchor to have even more control over where my legend is placed. You can see here by specifying 1, 1, this is in my axes proportion coordinate system, I place my axes just outside of I place my legend just outside of my axes, which is kind of interesting, right? By specifying 1, 1, we're expecting it to be outside. Well, the other piece of information here that we need is the location. Just like with our text, with the horizontal alignment needing to be left, center, or right, and that dictates where that point that I would place refers to, our location of this legend refers to which corner should I put at the coordinates at proportion 1, 1. It defaults to upper left since I didn't specify it. But if I put my upper right corner at 1, 1, we actually see that my legend is now drawn inside of my axis system. And we can take this a step further, use a little bit of itertools fun, and we actually have the ability to draw as many legends as we want, but I can demonstrate, right, when I use a location as the lower right-hand corner, right, we get an axis that is actually located in the top left. Just the lower right-hand corner is at 0.11. Same with the rest of these legends. And I hope you're wondering, well, Cameron, they can't all be at 0.11 because they don't, they're not touching. And that's because there is a default padding applied to legends, and you can actually eliminate this with this border axes pad argument. And so when you eliminate it, you actually end up with legends that are touching. And so I can do this at any corner of the plot. I can do this absolutely anywhere, and this lets me place my legend wherever I want. You can even create custom legends. All a legend needs are some labels, some text, and some handles. Handles are things that Matplotlib will use to plot. They're things like the circles from a scatter plot, the rectangles from a bar plot, the lines from a line plot. And what we can do is we can tap a little bit into Matplotlib and we can generate these things on our own. A patch is actually, we can use this as a rectangle in this case, and a line 2D, as you can imagine, is a line. And so what I'm saying here is that I want label 1 in my legend to correspond to a patch, a rectangle, that is green. And I want label 2 to correspond to a line that has no data, but a line that's purple. And when I take these labels and these handles, I do a little bit of unpacking, and then I throw them into the legend, we actually can generate a legend that has nothing to do with our underlying data. And I hope you're thinking, well, that's not very useful. Why would I want my legend to have absolutely nothing to do with my data? You want to have control of your legend to circumvent the pitfalls where calling axes or figure.legend fail you. And where they will fail you is when you have multiple axes with the same groupings that you want to then annotate a legend onto. Sure, you can draw the same exact legend onto your 3 different axes. So if I had this plot, I could draw a legend under coefficient 1 right in the top right. I could under coefficient 3 and coefficient 5 all in the top right. But then I have 3 legends that all just convey the same information. It gets a little bit noisy. What I actually might want is a figure legend. But when I just use fig.legend, I get absolutely every line that I've drawn onto my sheet of paper here. And so that's 3 sines and 3 cosines. It doesn't specify the coefficient. All I want, though, is just, 1 sine that's blue and 1 cosine that's orange. I don't need all 6. What we can do is we can, instead of instead of just letting Matplotlib do all the work for us, we can actually manually get the labels and the handles from one set of axes. Remember, each axis just has sine and cosine, and there's 3 sets of them. So we just refer to one of them, we get the labels and the handles, and we pass that to figure.legend, and we end up with this. And so what I would do here is I would actually adjust my figure to make sure that I'm including that right-hand side of the actual legend. See here that I've moved my plots over, squished them just a little bit to make sure that my legend is drawn on my sheet of paper. There's actually another way that we can do this. If I use ax.legend instead of fig.legend, we end up with a legend just in my last axes, right? Since I iterated over them, ax just refers to the last one. But what I can also do is I can just say ax.legend, right, with a specific anchor point. That gets me close, close-ish, right? I can just keep playing with that until it gets to the center right. Or I can use this idea of a transform again, and I can pass it the figure coordinate system, proportion coordinate system. And so this is referring to, 1, all the way on the right-hand side of my figure, halfway up my figure, and I want the point that I'm referring to from my anchor to be the center right of my legend. And so that ensures that my legend will be inside of my figure and not drawn outside. And so that's how we can draw our own custom legends. We can place them absolutely anywhere and have full control over them in order to make it pretty.